Welcome to Learner's Academy. Today, we're going to learn about polynomials, a concept in algebra that is most commonly used by math students. Polynomials might sound complex at first, but once you break them down, you'll see that they're actually pretty easy to understand. So, let's take this step by step. Before we jump into polynomials, we need to first understand what terms are, because polynomials are just combinations of terms. Okay, so in algebra, a term is a single mathematical expression that consists of two key components. The number part, like 2, 4, or 3.7, and the variable part, like x or y. Simply, a term is essentially a product of a number and a variable, though. We often don't write the multiplication symbol. So when you see something like 5x, the number 5 and the variable x are multiplied together. The 5 or number part is also known as the coefficient of the term, and the x is the variable of the term. You could have different combinations of coefficient and variables like 2x, 5y, or even more complex ones like 3x squared, y cubed. Now let's talk about the variable part of the term. This is where things get interesting. A variable represents a quantity that can change. It can be as simple as x or y, or it can be more complex like x squared or x cubed. These exponents or powers show how many times the variable is multiplied by itself. If the variable is x and it's squared like x squared, it means x is multiplied by itself, x times x. If it's cubed, like x cubed, it's multiplied by itself 3 times, x times x times x. You might even see more complicated combinations, like x squared times y cubed, or a times b squared times c cubed. The important thing to remember is that the exponent shows the degree of the term. Now, here's a cool fact. Even if the exponent is 1, we don't need to write it down. For instance, x is just x powered 1. We don't bother showing the exponent because it doesn't change anything. Similarly, when you see y alone, it's really the same as y powered 1. It's simple but important to note. Now that we know what terms are, let's see how they come together to form polynomials. A polynomial is simply a combination of multiple terms. Imagine a polynomial as a chain of terms, all linked together by addition or subtraction. The key is that each term is connected by either a plus or minus sign, but the terms themselves are made of multiplication. Polynomials can have any number of terms, and based on how many terms they have, they get special names. If there's one term, it's called a monomial. The prefix mono means 1, so it makes sense. If there are 2 terms, it's called a binomial, because bi means 2. If there are 3 terms, it's called a trinomial, where tri means 3. Anything with 4 or more terms is generally just called a polynomial, and we use poly because it means many. You'll hear the term polynomial often, even if there are only 2 or 3 terms. This is just the way to keeping things neat and tidy in mathematics. Let's look at a polynomial. Here's a typical example of a polynomial, 3x squared plus x minus 5. Let's break it down. The first term is 3x squared, which means 3 multiplied by x squared. The second term is plus x. The third term is minus 5, which is a constant term because it doesn't involve a variable. How many terms does this polynomial have? 3. If we break it down into its parts, we see that it's actually a trinomial. But wait, there's something odd here. The second term seems to be missing a coefficient, and the third term is missing a variable part. Let's analyze it. The second term, plus x, is actually plus 1 multiplied x. We don't write the 1, because multiplying by 1 doesn't change anything, but it's there. So the term plus x has both the coefficient and variable part. However, only the variable part is written and coefficient part, 1, is not written. That's why the term looks like just x. Now what about the third term, minus 5? Actually, this term also has two parts, the coefficient and the variable part. Mathematically, we can think of this as minus 5x to the power 0, because any number or variable raised to the 0 power is equal to 1, and anything multiplied by 1 doesn't change the value. This means that minus 5 is really just minus 5x to power 0. So we can confidently say that minus 5 is also a term. In cases like these, where we don't write the variable part of the term and we only have number part, then such terms are known as constants. The constant term is super important in polynomials because it's the term that never changes. Whether you're plugging in values for x or solving for y in a polynomial, the constant term stays the same. In our example, minus 5 will always be minus 5, no matter what happens with the other terms. This is why we call it a constant term. Now let's talk about a key property of polynomials, the degree. The degree of a term is simply the power of the variable in that term. For example, in 3x squared, the degree of the term is 2, because x is raised to the second power. In 6x, the degree of the term is 1, because x is raised to the first power. In minus 5, the degree of the term is 0, because it can be written as minus 5x to the power 0. What is the degree of 2x squared y cubed? Well, here we add the exponents of variables x and y, which is 2 plus 3, and the answer is 5. When we talk about the degree of a polynomial, we're usually referring to the degree of its highest term. So in the polynomial 3x squared plus x minus 5, the degree is 2 because x squared is the highest power of x. It's really important in mathematics to keep things organized. This is why we always arrange the terms of a polynomial in descending order of degree. So the polynomial x minus 5 plus 3x squared would be written as 3x squared plus x minus 5. Notice how the term with the highest degree, which is x squared, is on the left, and the constant term minus 5 is on the right. But what if a polynomial is having missing terms? Let's say you have a polynomial like 4x to the power of 5 minus 10x plus 8. This is a fifth degree polynomial with a total of 3 terms. Even though it's missing some terms like x to the power 4, x cubed, and x squared, we still arrange the terms by their degree, so we would write 4x to the power 5 minus 10x plus 8. One important point when rearranging polynomials is that we need to pay attention to the signs in front of terms. For example, if you have minus 5x squared, the minus sign is part of the coefficient. So when you rearrange the terms, don't forget to bring that negative sign along with the term. Normally, when we see a minus sign, we think of subtraction. But when it comes to polynomials, it's best to think of a minus sign as a negative sign, or in other words, it means the term right after the sign has a negative value or a negative coefficient. In fact, instead of thinking of a polynomial as having terms that are added or subtracted, it's best to think of all of the terms as being added, but that each term has either a positive or a negative coefficient, which is determined by the operator right in front of that term. For example, if you have this polynomial, you should treat it as if all of the terms are being added together, and use the sign that's directly in front of each term to tell you if it's a positive or a negative term. This first term has a coefficient of -4, so it's a negative term. The next term has a coefficient of +6, so it's positive. The next term has a coefficient of -8, so it's negative. And the constant term is just +2. And recognizing positive and negative coefficients helps us a lot when rearranging polynomials that have a mixture of positive and negative terms, like our example here. If you think of the negative sign in front of the 5x squared term as part of its coefficient, then you'll realize that when we move it to the front of the polynomial, the negative sign has to come with it, because it's really a negative term. If we don't bring the negative sign along with it, we'll be changing it into a positive term, which would actually change the value of the polynomial. And in addition to helping us rearrange them, treating a polynomial as a combination of positive and negative terms will be very helpful when we need to simplify them, which just so happens to be the subject of our upcoming video. Polynomials might seem complex at first, but they are just a series of terms connected by addition or subtraction. Once you understand the basics, like coefficients, variable powers, degrees, and constant terms, you'll be able to work with polynomials with ease. Alright, we've learned a lot about polynomials in this video, and if you're a little overwhelmed, just take some time and re-watch this video. As always, thanks for watching Learners Academy, and see you next time.